question number 8, which is the diagram shows a sketch of the curve y equals x power half times ln x and its minimum point m. The curve cuts the x-axis at point 1 and 1, 0. यहाँ पे find the exact value of x coordinate of m. So since m is the minimum point, we're going to start the question by derivating the curve's equation and equating it to 0. So dy over dx is equals to 0 at point m. So y is x power half ln x. So derivate करना है. So we'll use the product rule of differentiation, which is when we're derivating f times g. So you derivate f first, multiply it with g, then you derivate g and multiply it with it. Okay, so using that, it's going to be half x minus half ln x remains the same, plus x power half 1 upon x. Okay. So this gives us ln x, I'm writing 2 square root of x, because when this goes down, it becomes x power half, which is square root of x. And then plus square root of x upon x, and equate it to 0. Okay, we have to find the exact value of x coordinate of m. Alright, so find x from here. So what can we do? Let's take LCM. So the LCM is going to be 2x square root of x. Yeah, what we can do is multiply square root of x here with this fraction and multiply 2 here. So then we'll get 2x in the denominator. और numerator में आ गया square root of x ln x plus 2 square root of x equals to 0. So the denominator gets eliminated. So we just have square root of x ln x plus 2 square root of x is equals to 0. So square root of x common आ गया. ln x plus 2 equals 0. So square root of x is equals to 0, which gives x is equals to 0, which can't be possible because m पे x 0 तो नहीं है. M is not at the origin. So it's not that. So take the other bracket, ln x equals -2. Ln goes to the other side, so becomes e power minus 2. So the x coordinate of m, the minimum point is e power minus 2. Okay. The question है तो पूछो in the first part. Okay, part 2. Part 2 says use integration by parts to find the area of the shaded region enclosed by the curve, the x-axis and the line x equals to 4. Give your answer correct to do this. So we have to integrate the curve, which is x power half ln x dx. Upper power of x in the shaded region is 4. Lower power of x is 1. So ये solve करना. using integration by parts. Okay, so integration by parts में हमने follow करना होता है LIAPE. एक को U substitute करना होता है और एक को V dash. U substitute करना होता है इस sequence में. Log सबसे पहले आ रहा है. So there is a log term here. So ln x will be U. So V dash is going to be x power half. Now we derivate this. ln x की derivation होती है 1 upon x. Or this is the derivative of V. From this find V, that means we're integrating this. So integration of this will be x power half plus 1 upon half plus 1. It's going to be x 3 upon 2, and in the denominator is also 3 upon 2, which becomes 2 upon 3. So 2 upon 3 x power 3 upon 2 is V. Now integration by parts formula is U V dash integration is equals to U V minus integration of U dash V. Okay. So U is ln x, V is 2/3 x power 3 upon 2 minus integration U dash is again 1 over x and V is 2/3 x 3 upon 2. Okay. So ln x, this would be 2/3 x power 3 upon 2 ln x minus, let's simplify this. So we have 2/3 can come out of the integral because it's the coefficient, and subtract 3 by 2 and 1, that would be half dx. Okay. So we get 2/3 x power 3 upon 2 ln x minus 2/3 integration of x power half is going to be x 3 upon 2 upon 3 upon 2. And this I'm writing as 2 by 3. So it's going to be 2 by 3 x 3 upon 2 ln x minus 4 upon 9 x power 3 upon. Okay, now we substitute the limits, which were 1 and 4. So substitute 4 first, then the minus sign and substitute 1. So 2/3 times 4, 3 upon 2, ln 4 minus 4 upon 9, 4 times 3 upon 2. And then substitute 1. When we substitute 1, ln 1 becomes 0. So the first term becomes 0. This is 0. And minus 4 by 9, 1 power 3 upon 2. So when you simplify this, you get 32 upon 3 ln, well, can you 32 to नहीं आ रहा, just a second. Let me check हमने decimal में आंसर देना है या exact आंसर देना. correct to 2 decimal place. अच्छा, तो just enter all of this in the calculator and it will solve it for you. इसको further इस पे time spend करने की जरूरत नहीं है. Just appropriately use the brackets, solve it, and the answer would come out to be 4.2. Get this in decimals, get this in decimals, and subtract them, but maintain the accuracy. So use as many decimal points as you can, decimal places as. Please ask any questions if you have any. If not, then I will copy the next question now. Okay. The expression cos theta plus square root of 3 sine theta, express this in the form of r cos theta minus alpha, where r is greater than 0 and alpha is between 0 and pi by 4, giving the exact values of r. So part 1 is from trigonometry. So if you remember from trigonometry that r is simply found by kind of applying Pythagoras theorem on the coefficient of cos x and the coefficient of sine theta. So r would just be square root, you have 1 here. So 1 square plus square root of 3 square. So that's 2. And theta is tan inverse. The formula was y upon x. And this formula for r was square root x square plus y square, where again x is the coefficient of cos theta and y is the coefficient of sine theta. So we get tan inverse square root of 3 upon 1, which in radians gives us pi by 3. So, sorry, that's going to be alpha, not theta. ये हम find कर रहे हैं. So alpha is theta to theta ही रहता है. Okay, so alpha comes out with this. So now you just have to find r into. Rewrite करने को नहीं कहा. Rewrite करने को कहा होता तो फिर हम यूं लिखते 2 cos theta minus pi by 3. They did not ask for it, so it's not a compulsion. But part 2 mein we will be using this. Part 2 is, hence show that when you integrate 1 upon cos theta plus square root of 3 sine theta whole square. So instead of that, we're going to write the change form, which is going to be 2 cos theta minus pi by 3. Okay. So first of all, what I'm going to do is I'm going to bring out the coefficient, which is 1 by 4. So we get 1 by 4, integration limits are 0 to pi by 2. And now we have cos square theta minus pi by 3 in the denominator. अब ऐसा तो हमने कोई रूल नहीं पढ़ा हुआ इंटीग्रेशन का, that you have a function in the denominator and just 1 in the numerator and you get to integrate it. ऐसा rule नहीं पढ़ा था. हमने पढ़ा हुआ है कि if you have something in the denominator and you have the derivative of that in the numerator, then it becomes ln x. So that means this is not applicable here. But if you send cos square theta minus pi by 3 to the numerator, it becomes secant square theta minus pi by 3. And we know what's the integration of secant square. If you remember, the derivation of tan theta is secant square. So tan theta when derived becomes secant square theta. And secant square theta when integrated becomes tan theta. So that would be tan theta. When you integrate secant square theta, you get tan theta. So tan theta minus pi by 3, and in the denominator, you also have to derivate theta minus pi by 3. But the derivative of theta is just 1, and the derivative of minus pi by 3 is 0, because pi by 3 is a constant value. So in the denominator, you just write 1 minus 0, or even if you don't write anything, it's absolutely fine. There's 1 by 4 here, and now we integrate, substitute the limits. So we're getting 1/4 tan pi by 2 minus pi by 3 minus tan 0 minus pi by 3. That gives square root of 3 upon 3. Enter the entire thing in the calculator, you get square root of 3 upon 3. Did we have to give the answer in exact form or what? Hence, yes, that is acha. बल्कि इस फॉर्म में शो करना है 1 upon under root 3. So आपको कैलकुलेटर ये वैल्यू देता है under root 3 upon 3, which is the same as 1 upon under root 3. They're exactly the same thing. कैसे they're the same? You can multiply this with square root of 3 and this with square root of 3. So then in the numerator, you get a 3, and in the denominator, you get 3 square root of 3, which becomes this. But the first answer that the calculator will give you would be this. So convert करना होगा. Directly भी लिख सकते हो, but working show करते हो तो ज़्यादा अच्छा कि यहाँ से ये कैसा है. Okay. अब next question देखते हैं. Okay. Use the substitution u is equals to square root of x to show that I equals I becomes this. Okay. So we're initially given this integration with respect to x, and you have to use this substitution and change it into this. Okay, so let's do that. Whenever you be using substitution to integrate, always start with this, the given substitution. Okay. Then derivate it with respect to the variable on the left. It's going to be du upon dx, which becomes half x power half minus 1. So that becomes 1 upon 2 square root of x. Because we get half x minus half, which then goes in the denominator and becomes x power half, which is square root of x. Okay. So du upon dx is equals to that. That means dx is equals to 2 square root of x du. However, we can replace this square root of x with u. So dx is 2u du. So we have I equals, अब I'm not going to write 1 to 4 here क्योंकि मैं u की फॉर्म में चेंज कर रही हूँ तो लिमिट्स चेंज हो जाएंगी. So dx की जगह I'm going to write 2u du और यहाँ 1 है. x की जगह we're going to write u square because x would be equals to u square according to the given substitution. So u square and 4 minus u. So now this square and the u cancels out. So we have integration 2 upon u, 4 minus u du. And all that's left to do is change the limits from 1 to 4, which are the limits of x, into the limits of u. So we have the conversion u is equals to square root of x. So when x is 1, u is also 1. So x1 gets replaced with u equals 1. But when x is square 4, then u would be 2. So we write 2 here. Okay, so we have shown the conversion. That this converts into this if we use the given substitution. Part 2 says, hence show that I equals half ln 3, which means now we integrate it. Okay, so again, there's a function in the denominator, which is 4u minus u square. And we do not have its derivative in the numerator. So we cannot use the this rule of integration. जहाँ fx denominator में होना चाहिए और उसका derivative numerator में होना चाहिए. So that becomes ln fx. ये तो नहीं यूज हो रहा. इसके अलावा डिनोमिनेटर में जब फंक्शन हो तो ये भी हो सकता है कि वो पूरा फंक्शन ऊपर चला जाए. फॉर एग्जाम्पल अगर बस इस तरह से होता x या u plus 3 whole square, then we would have sent it up. और अब हम पावर रूल यूज कर लेते हैं इंटीग्रेशन जो as में पढ़ी जाती है. This one. This gives us fx n plus 1 upon n plus 1 times f prime x. लेकिन यहाँ तो ये भी नहीं हो सकता because we don't have a whole power. on this entire function जिसको हम ऊपर ले जाए. Even that will not work. उसके अलावा डिनोमिनेटर में जब आता है तो ये केस भी हो सकता है 1/1 plus x square dx, which is equals to tan inverse x. Either this और या x की जगह पूरा फंक्शन होता है, so fx whole square. अगर ऐसे हो तो फिर न्यूमरेटर में उसका डेरिवेटिव भी होना चाहिए, and that is equals to tan inverse fx. This isn't that case either. So that's, let's say 1, 2, 3. ये दोनों मिलके 3 है. Okay. So this is neither 1 nor 2 nor 3. एक और केस भी रह गया जिसपे हमारे पास डिनोमिनेटर में एक फंक्शन आ रहा होता है और उसमें हम अप्लाई करते हैं पार्शियल फ्रैक्शन. सो दिस इज दैट केस कि हम 2/u टाइम्स 4 - u को पार्शियल फ्रैक्शन में ब्रेक कर लेते हैं और फिर हमारे पास u सेपरेट हो जाएगा डिनोमिनेटर में और 4 - u सेपरेट हो जाएगा और फिर हम मोस्ट लाइकली ये यूज कर लेंगे या ये यूज कर लेंगे. लेट्स सी, probably first वाला यूज हो जाएगा. So now we're going to apply partial fractions on 2/u times 4 - u. So 2/u times 4 - u in partial fraction would be written as a/u plus b/4 - u. LCM gives us a times 4 - u plus p times u upon u times 4 - u. This cancels out and we have 2 equals a 4 - u plus bu. Let u is equals to 0. That gives us a equals half. And then let q equals 4. That gives us b equals half. So this becomes half 1/2u plus 1/2 times 4 - u. So we're going to integrate the partial fraction. So 1 to 2, 1/2u plus 1/2 4 - ut. Split the integral sign. So we have, I'm going to bring out the coefficient, which is half, plus another half, integration from 1 to 2 of 1/4 - ut. Okay. Now we have simple linear functions in the denominator, and we may have the derivative in the numerator as well. Let's check. And this would be equals to ln fx. So the derivative of u is just 1, which is already there in the numerator. The derivative of 4 - u would be 0 - 1, which is -1. तो ऊपर -1 होना चाहिए, नहीं है. So we can fix that. हम यहाँ पे भी माइनस लिख लेते हैं और यहाँ पे भी माइनस लिख लेते हैं. The minus time minus actually becomes plus, so we haven't really changed anything about the expression. So this becomes half ln u, limits to 1, then minus half ln 4 minus u, limits to 1. क्योंकि limits same है, let's write it together. That makes the job easier. So it's going to be half ln u minus half ln 4 minus u. And now apply the limits to 1. I think इसका आंसर exact form में दिखा. Yes, half ln 3 आना चाहिए. So you can't just substitute everything in the calculator. Okay, substitute the values. We get half ln 2 minus half ln 2 and then minus sign. We get half ln 1 minus half ln 4. Sorry, that's 3. Okay. This becomes 0. Also, this is 0. So we have another 0 minus half ln 3, which gives us half ln 3, which is what we were supposed to. Oh. Let's start the next question. Let fx equals that. Express fx in partial fractions. That's going to be x squared plus 3x plus 3 upon x plus 1, x plus 3 equals, since they're just linear factors, it's going to be a upon x plus 1 plus b upon x plus 3. Take LCM here.
मैम
Hmm.
पहले लॉन्ग डिवीजन नहीं करनी चाहिए थी, इम्प्रॉपर फ्रैक्शन है ये.
हाँ, yes, definitely. ठीक है, my bad. बिल्कुल सही है, पहले लॉन्ग डिवीजन करें वरना आंसर गलत आएगा. ओके, सो डिनोमिनेटर में आ गया एक्स स्क्वायर प्लस 3x प्लस x प्लस 3. लॉन्ग डिवीजन हम तब पहले करते हैं. अच्छा, ये बन गया एक्स स्क्वायर प्लस 4x प्लस 3 और यहाँ आ गया एक्स स्क्वायर प्लस 3x प्लस 3. तो लॉन्ग डिवीजन तब करनी होती है जब आइदर द powers in the numerator and the denominator they're the same or the power in the numerator is bigger. So either same है तो long division तो हो. Okay, long division कर लेते हैं. So x square plus 3x plus 3 and x square plus 4x plus 3. So 1 ही आएगा क्वेश्चन पे. So that's going to give us x square plus 4x plus 3. Subtract करेंगे. Minus, minus, minus. This gets eliminated. We get minus x. And that's it. 3 also gets eliminated. So now this becomes 1 whole minus x at the top and x square plus 4x plus 3. इसको mixed number में लिख लिया. ये यहाँ आ जाता है, ये यहाँ आ जाता है और ये यहाँ आ जाता है. सो वी हैव वन आ चुका है हमारे पास, और साथ एक फ्रैक्शन आ गया -x। अच्छा नहीं, बल्कि वन को अभी इग्नोर करो और इसकी अब पार्शियल फ्रैक्शंस करेंगे। ठीक है। अच्छा, अनदर थिंग, जब हमने मिक्स नंबर लिखा होता है लाइक 1/2/3, इसका मतलब होता है इट्स एक्चुअली 1+2/3। जब हमने लिखा होता है 7.5 एज अ मिक्स नंबर, उसका मतलब होता है 7+½ राइट। सो दिस इज 1 प्लस दिस फ्रैक्शन। सो हम इस पिंक पार्ट की पार्शियल फ्रैक्शन करेंगे और उसके साथ 1 एंड में ऐड कर देंगे पार्शियल फ्रैक्शन के रिजल्ट के साथ। ओके, सो लेट्स स्टार्ट। Going to be -x upon, write the denominator in factorized form, which was x+1 and x+3. So factorized form में दोबारा लिख लिया. Now this would be equals to a upon x+1 plus b upon x+3. LCM ले लेते हैं. जब मैंने एफएससी किया था, वैसे आई डोंट लाइक टू टेल माय स्टूडेंट्स कि मैंने एफएससी किया था, बिकॉज खैर चलो, एनीवे, तो फिर मैंने एफएससी किया था, सो आई गॉट 95 आउट ऑफ 100 इन माय सेकेंड ईयर एग्जाम, व्हिच इज लाइक इक्विवेलेंट टू A2 फॉर यू गाइस। और उसमें 5 मार्क्स का क्वेश्चन पार्शियल फ्रैक्शन का था, और ये मैंने लॉन्ग डिवीजन में की थी। और एफएससी में ये होता है कि थोड़ी ज्यादा स्ट्रिक्ट मार्किंग होती है, तो उसके कोई मार्क्स नहीं मिलते। सो आई लॉस्ट दोस 5 मार्क्स, और उसके बाद से मुझे कभी भूला नहीं, लेकिन आज फिर भूल गया आफ्टर सो मेनी इयर्स। लेकिन हैवी पेनल्टी होती है अगर आप ये लॉन्ग डिवीजन वाली चीज को ओवरलुक कर दें। आई एम प्रीटी श्योर मार्किंग स्कीम भी काफी स्ट्रिक्ट होगी, आपकी भी स्ट्रिक्ट होगी, पूरे नहीं लूज करा देंगे, मे बी 1 मार्क दे दें। अगर ये 3 या 4 मार्क का है तो मे बी 1 मार्क आपको मिल जाए, लेकिन मे बी 2 भी मिल जाए। कुछ मार्किंग स्कीम ज्यादा फॉरगिविंग होती है, लेकिन फिर भी यू कैन नॉट फॉरगेट, यू शुड नॉट फॉरगेट कि ये भी करना होता है। लॉन्ग डिवीजन हमेशा चेक किया करो पहले कि लॉन्ग डिवीजन तो नहीं हो रही, और वो कब होती है, जब न्यूमरेटर की डिग्री इक्वल हो डिनोमिनेटर की डिग्री से या बड़ी हो। पर अब ये क्वेश्चन होमवर्क में जाएगा क्योंकि वे रनिंग आउट ऑफ टाइम। सो 11 और 12 होमवर्क में करोगे, एंड आई विल सी यू गाइस ऑन मंडे इंशाल्लाह। टेक केयर, अल्लाह हाफिज।